Introduction to Forging. Welcome to this session on Introduction to Forging. In our daily lives, we use many metal tools and parts. Have you ever wondered how they are shaped? Metals are shaped through a process called forging. An understanding of the heat treatment process and the forging process is essential before we begin forging metals to various shapes. Let's now look at the key objectives. At the end of this session, you will be able to describe the various operations involved in forging, describe the heat treatment process of plain carbon steel. Forging is a manufacturing process which involves heating metals to the plastic stage and then shaping those metals using localized compressive forces. Blows are delivered using a suitable die and hammer until the metal's final shape is obtained. There are many different kinds of forging processes. However, they can be grouped into three main classes. Draw out. Drawing is used to reduce the cross-sectional area of the workpiece while concurrently increasing its length. Upset. Upsetting increases the diameter of the workpiece by compressing its length and is used to forge engine valves, couplings, bolts, screws, and other fasteners, etc. Squeezed enclosed compression dies. It produces multi-directional flow and is used to forge engine crankshafts, connecting rods, gears, etc. Let's now review in some detail the common operations used in forging. Drawing out. Drawing out is a forging operation by which the cross-section of a piece of stock is reduced and the length of the piece is increased. A fuller and a sledgehammer are used for drawing out. It is done on the face of an anvil. The steps involved in drawing out are setting the stock, necking, fullering, and finishing. Upsetting is a process of increasing the cross-sectional area of a work by shortening its length. One of the simplest methods of upsetting is to place the article on the anvil and hammer it directly on the upper end. The effect of the blow has a great influence upon the shape of the work. Upsetting is of three types. End upsetting. Upsetting any one end of the workpiece. Center upsetting. Upsetting the center of the workpiece. Jumping. Full upsetting of the workpiece. Precaution. The following are the preventative safety measures which should be taken while forging. Heat the metal to the forging temperature. Upsetting is to be done on a bent metal after it is straightened. The length of the metal should not exceed 2 to 2.5 times the diameter of the work. Hammering should be done on the center section of the upper end. Heat treatment process and purpose. Heat treatment is an operation or combination of operations involving heating at specific rate, soaking at a temperature for a period of time, and cooling at some specified time. The aim of the heat treatment is to obtain a desired microstructure to achieve certain predetermined properties like physical, mechanical, magnetic, or electrical. Heat treatment processes applied to steel can be briefly classified as hardening, tempering, annealing, normalising. Hardening. Hardening is the process of sudden cooling, quenching, of steel from its upper critical temperature. This results from the formation of martensite, which induces hardness in steel. Now, the steel is in a stress stage and very brittle. At this stage, it cannot be used for practical purpose without further heat treatment. So the hardening process is followed by a tempering process. The purpose of hardening is to increase hardness, strength, and cutting ability, and to develop wear resistance and reduce ductility. Tempering. Tempering is the process of reheating the hardened steel to a temperature below 400 degrees Celsius and then cooling it back down to room temperature. The tempering temperature depends upon the purpose for which the article is to be used. The purpose of tempering is to relieve internal stresses, regulate hardness and toughness, decrease brittleness, restore some ductility, and improve shock resistance. Annealing. Annealing is a softening process which involves heating metal to above upper critical temperature and then soaking it for a sufficient amount of time until its grain structure transforms. Once this transformation has taken place, it is slowly cooled down in the furnace to room temperature. Annealing is done to soften steel, improve machinability, increase ductility, and relieve internal stresses. Normalising. During normalisation, the metal is heated to a temperature 40 degrees to 50 degrees Celsius above the upper critical point and soaked at that temperature. It is then cooled in free air at room temperature. This process is used to regain structure, relieve stresses, impart toughness, reduce ductility, and prevent warping. With that, we have come to the end of this session. In this session, we learned to describe various operations involved in forging, describe the heat treatment process of plain carbon steel,